Hello, this is my computer 2560, assignment 1. My name is Ran Shami, um, and here are my files in my desktop directory for com2560 underscore assignment 1. Let me open a terminal and start. Okay. So, let me show my username, Womi. So if I use this command, you can see it's my no machine shows Shami R, my name, my username for the university, and I'm currently in my com2560 underscore assignment 1 directory on the CX Linux server, and here you can see all the seven source code files that were required for this assignment. So let me just show them. There we go. So we have ACQ1.c, 3, 4, 5, 6, 7, and then writer.c. So let's just start with question 1. Let's get straight into it. So for question 1, I need to use the lseek function to find the size of a file. If I can just get my file here, cat acq1.c. So here we can see, looking at my code, I open the file using the open system call, and then I use lseek with seek underscore end to move to the end of the file, and then the return value from lseek gives me the file size in bytes, which I then print to the screen. So let me just compile it, and then I'll run the program. And then I'm going to use the echo command to get my test file. So we copy from my notepad, and then if we paste it, we see that my file size has 35 bytes. And then just to verify that this is correct, I'm also going to use the ls command with the -l flag, and then that'll basically show me that it's the same thing, which would be proving that my implementation works. So this should also be 35 bytes, which is also correct. I get 35, which means the implementation works correctly. Now for question 2. So question 2 requires creating a formatted file called list1.txt using exactly one write call. So in my code, I create a single string with the exact formatting specified. So the 3 spaces between the first 2 columns, tab characters between the other columns, and then new line characters at the end of each row. So let me compile, and after compiling, so okay, so the list1.txt was created successfully. If I use the more command to display the file contents, we will see that you can see here the formatted table with the proper column alignment exactly as it was required in the assignment. GM Ford, Buick Lincoln, and we have everything aligned here. Let me just exit here. Now if I'm using OD -C, to show the actual character representation, you can clearly see that the three space characters, the tab characters displayed as \t, and the new line characters as \n. So that proves the internal formatting is correct. And then finally, if I also use this command xxd for the same text file for list1, this will show the hexadecimal values where 20 represents spaces, 09 represents tabs, and like 0a would represent new lines. So this confirms the character storage matches the assignment requirements. Now for question 3, here's my code for ACQ3.c. I need to count lines in a text file using system I/O calls. So my implementation opens the file with open, reads it character by character using read, and then it increments a counter for each new line character encountered. I also handle the edge case where the last line doesn't end with a new line. And now let's see how it would work when I run it. And here's my command, my echo command from question 3. I copy it from my notepad, paste it. There we go. So I've created, I was able to create the test file of 3 lines, and then when I run the program and provide the file name, it correctly counts and reports 3 lines using the system I/O calls. So that works. It shows the number of lines being 3, and I had 3 lines, so that's good. And then that's all for question 3. And then now for question 4, here's my code. And then question 4, so that requires the same line counting functionality, but using standard I/O instead. But yeah, so just using standard I/O instead. And here I use fopen instead of open, and then I use fgetc instead of read, and then the same logic to count new line characters throughout the file. So just gonna compile and run it, and you'll see how it works. So now I'm gonna put this dot slash ACQ4. So now I ran the program with the same test file, and it also reports 3 lines here. It's demonstrating that both the system I/O and standard I/O methods can solve the same problem correctly, and it produces the identical, and it can also produce identical results. So we got the number of lines being 3, and then we also had on question 3 the exact same number. So just proves that they can have identical results. Now for question 5, here's my code. So question 5 demonstrates file operations using system I/O calls. The program displays file content, takes the user input, and then it appends into the file, and then it shows the updated content. So what I did is I use open with O underscore R Donley for reading, and then O underscore Ronley combined with O underscore append for the append operation. So let me compile and then run it. So when I run the program, you can see it first displays the original file content, and then it automatically appends the predefined text, and it finally shows the updated file with the new content added to the end. So it's all accomplished using system calls. You get the original content with the line 2, and then the updated content also with line 2. And that's it for question 5. Now going on to question 6. Here's my file. So question 6 implements the same display and append functionality, but using the standard I/O. So I use fopen with R mode for reading, A mode for appending, and then fgets for reading lines, and then fprintf for writing the append text. So I'm going to do the same thing here as the other questions. I'm going to compile and then run it. So now I'm prompted to enter a text. I'll just text this text. I'm just gonna put this text was appended using standard IO. And then there, the program successfully adds my input to the end of the file using standard I/O functions, and it demonstrates basically that the same functionality as question 5, but with a different API approach. Now for question 7, here's my code. So for question 7, I need to create a file with a hole using standard I/O, similar to the text similar to the example I got from the from another file. So my code writes data at the beginning, and then it uses fseek to jump forward to 100,000 bytes, creating a hole, and then writes more data at the end. So compile, do the same thing. Okay, so the file of hole is created. So it says I can check with ls minus l, and that would show the large size, and then I can do the same thing with du minus h, and it would show the small usage. So let's do both, and we will see the results. Starting with ls minus l. So we see it's so we do see that it's ls minus l shows the logical file size, and it's over 100,000 bytes. And then when I use du minus h, it'll only show me the actual disk usage, which is only 8 kilobytes. So this basically demonstrates that the operating system doesn't allocate physical disk space for the whole, only for the actual data proportions. So that's basically it for my assignment. This completes my computer system programming comp 2560 assignment 1 submission. Thank you for watching, and have a good day.